Good morning, ladies and gentlemen. I am your host, Gordon Zulu. So today we are going to look at the loan payments where we have this formula to guide us. L is the loan which was borrowed from the lending institutions, while R is the rate of interest. Remember, when we are dealing with this topic, we need to understand one thing. What is that thing? A loan is said to be amortized. I am now explaining this L, why it is so. Remember, loans, they do not depreciate. Why? Because the loans, they don't lose value, so they are said to be amortized. So a loan is said to be amortized if both principal and rate are to be paid by a series of equal payments made at equal intervals of time, assuming a fixed rate of interest throughout. So when we are dealing with this, we need to understand one thing, where this is what is called the recovery factor. So this recovery factor is a factor that enables us to repay this loan when this value is known. How are we supposed to do that now? So with me, I have two examples to help you understand this, how the formula works. So these are the two examples that I have. The first one there reads to say a mortgage of 2,000 is to be repaid over a period of 25 years at a fixed interest of 4.5%. The second one says, suppose that WUPE received information on the mortgage loan that a late father signed. So we'll start first by solving the first one, and we apply the formula. Remember, this formula here can be manipulated by dividing the rate by M and also this rate by M and multiplying this by M. Remember, M is the number of compounding periods. So if you check the question that we had, a loan of 200,000, it says calculate the monthly repayments. Already we are dealing with the compounding periods, where we divide this rate by 12 and multiply the time by 12. So let us substitute in the formula with the required pieces of information so that we calculate the value of the A node which must be repaid back every month to mitigate the loan. So the loan in this case is the 200,000. So we just replace 200,000. The rate of interest is 0.045, where we said, remember, we had the number of compounding periods to be 12. We divide this by 12. 1 minus 1 plus 0.045 divided by 12, and we multiply this time. Sorry, I don't have enough space. Kindly 25 here. Thank you. So from here now, what we'll be able to do is we go further in punching here. So the first thing we'll punch is 0.045 divided by 12 and multiply it with 2,000. So when we multiply that with 200,000, so when we multiply this with this, it will give us 750. And you also divide and add, then you power it to negative 12 times 25. Then the result, you subtract it from 1. So this is the result we are going to get. So this is the result, where if we just divide here, 750 divided by the 0.675, we're going to get our answer as 1,111.1. So this is the monthly payments that must be paid in order to mitigate the loan, which is the 200,000 we were given in the first place. We are now going to solve this question, though it requires a little bit of thinking, but don't get discouraged. The process might seem to be so tiresome, but that's the journey of school. So the information reviewed the remaining balance of this. So this was the amount that remained after a loan was borrowed. So this, in short, is the loan, while these are the payments that are supposed to be made in order to mitigate this. So we just replace now in our formula. Remember, they want the she wants to know how many payments are left. She wants to know. So in total here, we are calculating the time. So we just replace in our formula where we have the loan which was being repaid is the 3,188.09. The monthly repayments are 733.76. Where the rate, we convert it to a decimal, it becomes 0.08. Then they said monthly payments, where we divide this by 12. 1 minus 1 plus, where r is just the same which is on top, 0.08 divided by 12, then we power to negative t like that. So from here now, we'll go directly by, remember I can put this in brackets to suit the needs of interest. So we'll divide both sides by this number. Assume we are dealing with 2a is equal to 4, where we will divide both sides by 2. Regardless, even if there is a b here, remember you can just say 2 is common here. So we use this theory to divide what is here. So we'll just divide 36188.09 33188.09. So we divide, we'll get our answer to be 0.08 over 12, 1 minus 1 plus 0.08 over 12 to the power negative t. So we divide 733.76 divided by 36188.09. We get our answer to be 0.0203. So immediately we have this now. We can now multiply what is down to here. So this times that one, we'll have 0.0203. 1 minus 1 plus 0.08 over 12 to the power negative t is equal to 0.08 over 12. So we will now divide both sides by this. Don't multiply it with what is inside because it will make life a little bit complicated. So just divide here, also divide there. So we have 1 minus 1 plus 0.08 divided by 12 to the power negative t. So we just divide 0. Divided by 0.0203. So we get our answer to be 0.328, where this one can go to the other side, but let's remove this negative. So let's allow this to cross over so that this can also cross over. So we will have 1 minus 0.328 is equal to 1 plus 0.08 divided by 12 to the power negative t, where we'll subtract those. So we'll have 1 minus 0.328, and we'll get our answer to be 0.672. 0.672. Then remember, you can remove this negative, that is negative indices. I guess we learned that. 1 plus 0.08 over 12 to the power t. Then from here now we can cross multiply again, where we will have 0.672, the same. We'll multiply it, so we'll have 1.0808 over 12 to the power t is equal to 1. Then from here we'll divide both sides by the 0.672, also here by 0.672. So we'll have a balance which is remaining 1 divided by 0.672, that is 1.488. So 1 plus 0.08 over 12 is equal to 1.488. So from here we can now introduce natural logs. So logs 1 plus 0.08 over 12. We'll introduce them both sides, 1.488. Where the t will go to the second, to this down part, we'll drop the t from the power coming at first. So we have t log 1 plus 0.08 over 12 is equal to log 1.488. Then from here we'll divide both sides by log. 1 plus 0.08 divided by 12. Also here log 1 plus 0.08 divided by 12. So from here now, we'll just punch. I will first do what is down here. So 0.08 divided by 12 plus 1. And I will say now log 1.488 divided by log, open bracket, the answer that I found. So giving me 59.8, in this case 60. So we have 60 payments left. So this is the value for our T. Thank you, and don't forget to subscribe. Remember to share, like, and comment. Thank you.